All right, so for today's lesson, we're going to be solving radical equations and radical inequalities. So let's get right into some examples like your homework. The directions here, of course, say in your book, they'll tell you to solve each equation. Notice that the next sentence I've basically marked out because it says to confirm by using a graphing calculator, which you do not have to worry about, so just ignore that. But then I do want you to do this last sentence that says to check for extraneous solutions, and we'll talk about that, what that means in just a minute. All right, so to solve this radical equation, the first step that has to take place, very important first step, is to isolate the radical part of this first. So I'm going to make this little note for you as a reminder. So in other words, the radical part of this on the left side of the equation has to be by itself, which means my first move is going to be to add 4 on both sides of this equation. So that produces the square root of 2x plus 5 equals 7. Now to undo the square root of, I just raise this left side to the second power. The effect of this is to make the radical, basically it will cancel out the radical and leave me with just 2x plus 5. But remember, if I raise the left side to the second power, I also have to do the right. So the right side becomes 49. And now I just take this simple equation and follow the normal procedure to solve for x. So I would subtract 5, and then I'll divide by 2. And so this is where this sentence, check for extraneous solutions, comes in. There are times where we come up with a solution, but when we plug it in, it actually doesn't work. It doesn't make the left side equal the right side. So you should at least do a mental check. I'm not saying you have to literally write it down, but if you leave an answer like this and you circle it, when actually it doesn't make the two sides equal, then that problem is going to be counted wrong. So let's see if 22 actually is a legitimate solution. So 2 times 22 is 44, and 44 plus 5 is 49. The square root of 49 is 7, and then 7 minus 4 is 3. So I'm going to go ahead and circle this now. I do not have an extraneous solution in this case. I have an actual good working solution. Okay, so once again, isolate the radical first. So that means I'm going to have to subtract 6 from both sides. Now I'm going to raise both sides to the second power to get rid of the square root. It's going to leave me with 4x plus 8 equals 9. Subtract 8 from both sides. Divide by 4 on both sides. And then just do a check and make sure that this actually works. So 4 times a fourth is 1. 1 plus 8 is 9. The square root of 9 is 3. And 6 plus 3 is 9. So as it turns out, 1/4 is an acceptable answer. When you have two radicals, you just want to make sure that they are on the same, or I'm sorry, they're on opposite sides of the equation. If they are on the same side, we need to put them on opposing sides. So this equation is already set up that way. So all we have to do is raise both sides of this equation to the second power, and that will remove both radicals. And now we just go about our normal routine solving for x. I'm going to subtract x from both sides, and I'm going to add 13 to both sides. And when I check this to make sure it's correct, I put 9 in for x. This gives me the square root of 5 on the left side, and 18 minus 13, also 5, so the two sides match when I put 9 in for x, and so this is a good answer. Okay, we talked earlier how a fraction exponent is really the same thing as a radical. This is also known as the cube root of 5p minus 7. So when you see this, it's really the radical that you need to isolate. So I need to isolate this part of the left side of this equation. So my first move will be to subtract 3 from both sides. And now consider this the radical. Now to undo raising this to the 1/3 power, I just raise it to the 3rd power. You will just raise the side to whatever the reciprocal power would be. And these two would basically cancel each other out, leaving you with 5p minus 7 on the left. But since I raised the left side to the 3rd, I also have to raise the right. And so that's going to make 8. Solve for p. And you get p equals 3. And we'll go ahead and check this one. 5 times 3 is 15. 15 minus 7 is 8. This means the cube root of 8 is 2. And then 2 plus 3 is 5. Okay, so the answer here again is 3. 15 minus 7 is 8. The cube root of 8 is 2. 2 plus 3 is 5. So we're good there. Okay, so once again, this would be considered the radical, even though it's written as a fraction exponent. That's the same way as writing a radical. So I need to do the 2 steps that are needed to isolate the radical first. So my first move is going to be to add 6. And then I need to undo this multiplying by 3 with division by 3. Okay, so I have successfully put the radical by itself on the left side, and so now I undo this 1/3 exponent by raising it to the 3rd. They'll just cancel each other out, leaving me with x plus 5, but I also have to raise the right side to the 3rd, and x plus 5 equals 8, so x equals 3. So once again, you could check this out. You do need to check it out, at least mentally, and make sure that it actually works. Okay, here's another radical equation. So isolate the radical first, add 4 to both sides. And since this is a cube root, I'm going to raise both sides to the 3rd power. And that's going to basically cancel out this cube root radical. Leaves me with 4n minus 8, and 4 to the 3rd power is 64. Now solve for n. 4n equals 72. N equals 18. And that's my final answer for letter C. Letter D, the radical is right here. It's the cube root of 14a. So I need to undo multiplying by 1/7, and I can do that by multiplying by 7. So these will just wipe out. So 14a to the 1/3 power equals 7. And then again, the way I undo this cube root, I just raise it to its reciprocal. The reciprocal of 1/3 is 3. So those will cancel. 14a, and make sure you raise both sides to the power. 7 to the 3rd is 343. And then when you divide by 14, you get 24.5. Okay, our final examples involve inequalities, and I've given you a list really of steps here to follow. If you follow these 3 steps, you should be good. There's a lot of similarities in the way we solve these with what we did with equations. But there's a couple of things that you need to be aware of. First of all, we've got to make sure that when we solve for x, we don't create a negative number under here, because the square root of a negative number means it's not real, and we have to come up with real number answers. So step 1, as I've listed it out for you, is pull out this part that's underneath the radical. It's called the radicand. And we're going to make sure that we make our answers so that x is going to be a number, a result that's greater than or equal to 0. So what we're doing here is we're finding out what those numbers are that are going to be acceptable. All right, so I'm going to subtract 14 from both sides, and then I'm going to divide by 2. And my numbers, when I get my final answer, I have to make sure that they agree with this. All right, so let's set that aside. And now we're just going to solve the inequality just like we did a minute ago with equations. So I'm going to add 6 to both sides. I'm going to do both sides to the second power. And now I'm going to solve for x. Subtract 14, divide by 2. Okay, so my overall solution says that it's any number greater than or equal to 43, but I need to check that against this, because if there are numbers in this set that violate this, I can't use those, because numbers that are less than -7 are going to create a negative number under the radical. So in this particular case, my overall solution is all numbers greater than or equal to 43, and that's true for all of these. Obviously, all of those numbers fit this description, so this is going to be my overall solution. Okay, so let's try another one. Once again, your starting point for these inequalities will be to take the radicand, in this case 4x minus 4, and make it be greater than or equal to 0, and find out what the numbers have to be in order to keep them real. So my overall solution has to be numbers that are greater than or equal to 1. All right, so let's keep that in mind. And now we're going to solve the inequality. I'll just go ahead and add 2 to both sides to isolate the radical. I'm going to square both sides. I'm going to add 4 to both sides and then divide by 4. So my overall solution said that it can be any number less than 10, but up here we said that to keep the answers real, they have to be greater than or equal to 1. So here's an example of when I'm going to have a between statement. It's really going to be all the numbers bigger than 1, but at the same time they have to be less than 10. Or in other words, they have to be between 1 and 10. So the way we write these between statements is just put the two numbers that you ended up with, two separate answers, just put them in numerical order, lowest to highest, and then x represents the solution, which is between these two numbers. And then the inequalities that go in these spaces are always going to be less than. They always point the same direction, and they always point less than. And this one, since it says x is greater than or equal to 1, well, I need to go ahead and include this or equal to x is greater than or equal to 1. So that's my final answer for letter B. Okay, let's try one more. So the first thing I'm going to do is solve this to see what x has to be in order for my answers to be real numbers. So I've got to make sure that my answers are any number greater than or equal to 2. Okay, so when I solve the inequality, I'm going to go ahead and subtract 3 from both sides. And I'm going to square both sides. And then solve for x. 5x is less than or equal to 35. X is less than or equal to 7. So I'm going to have all the numbers between 2 and 7. And so the way I write that is put 2, 7, and I put x between them. And then both of these are less than. And in this case, they're both less than or equal to. So my final answer will be all the numbers between positive 2 and positive 7. Okay, so that's the way your homework is going to look, and I've got the assignment posted for you on RenWeb, so make sure you get the assignment there. And if you have any questions about this, just let me know.